Hi future doctors, welcome to the next class. In this class we are going to discuss about errors, accuracy, precision, absolute error, relative error, percentage error, all this. First of all, how the error is going to come. So, error will be coming because of that device we are going to use for measurement. So I have given for you three different scales initially. So one is between 0 and 1, only one division will be there. So between 0 and 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 1. Between 0 and 1, how many divisions are there? 10 divisions are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, like this. Here between 0 and 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now between 0 and 1, 20 divisions are there. This is the scale. Now by using this we can measure least value, least count 1 centimeter. By using this least value 1 by 10. 1 by 10 means 0.1 centimeters. This is going to be least count value 1 by 20. So what is 1 by 2 here? So 1 by 2 is 0.5 by 10. 0.05 centimeters. Correct? Now, if you wanted to measure length of an object, that object I am placing like this. This is an object. If you wanted to measure length of this object. Now, what is the length of this object by using this scale? Means 1 is correct value, but this is there in between 1 and 2. Therefore, how you will take length of this object means length is nothing but 1.5 centimeters. How this 0.5 came means you assumed because it is there in between 1 and 2. So, this assumed value we are calling it as uncertainty. So, the uncertainty in the measurement we are calling it as error. This is not error because this is exactly there on scale. Next up, same object if you are placing here, let us assume it is coming like this. Now see, same object if you are placing here, you assume it is 1.5, but here it is going to be in between 1.5 and 1.55. So see here, in between 1.5 and 1.55. So if you see very clearly, this is 1.5, this is 1.55. The object is coming in between like this. So length of this object, how we will write means 1.55 centimeters. So 1.5 is clear, but this one we assumed it is there in between 1.5 and 1.6. Therefore, I write 1.55. This is going to be again uncertainty. So this uncertainty in the measurement we are calling it as error. Next up, what is accurate value? What is having precise value or precision? What is accurate means? How we will define accurate value means how close to the true value. How close to the true value is nothing but accurate value. So precision, up to what resolution, up to what limit? Up to what limit or resolution you are going to measure, that is going to be precision. How you will define precision means very simple, least count of normal scale 0.1 centimeter, this is normal scale. So least count of vernier caliper 0.01 centimeters vernier calipers. So least count of screw gauge 0.001 centimeters. Now which is having most precise value means after 0 how many decimal places are there you can see. In this only one decimal place 2, in this 3. Therefore most precise value which is having most decimal places. Let us assume 1.5, 1.55 1.567, which is having most precise value means 1.567. How you will define accurate value? So accurate value is nothing but, let us assume you have one measurement, true value 3.8 centimeters. You have taken three values. One is 3.6, 3.7, 3.75. Now which is 3.75? Now which is accurate value means how close to the true value? 3.75 is close to the 3.8. Therefore, 3.75 is nothing but accurate value. This is about accuracy, precision. Now we will see errors, absolute error, relative error, how it is going to come. We will see according to formula how you have to solve the problems. Next, we are taking three measurements, A1, A2, A3. Now, how you will get true value for this? So, if you are taking as formula wise, you may not understand. If you take values, you are going to get idea. Just first I am giving formula for you. How you will get true value means, always true value is nothing but mean or average of this A1 plus A2 plus A3 by 3. Now, absolute error. What is the error? Absolute error in A1. So, absolute error is denoted with delta A1. This one will be coming A true value minus A1. Like the delta A2, A true value minus A2. Delta A3, A true value minus A3. Next, delta A mean. So, delta A mean means again average of all absolute errors. Delta A1 plus, delta A2 plus, delta A3 by. So, delta A3 by 3. Next, relative error. So, what is meant by relative error? So, relative error means absolute error by measured value into 100 is not required. Percentage error is nothing but into 100. Delta A1 by A1. This is relative error in A1. So, percentage error. Percentage error means you have to multiply with 100 percentage error. So, just if you are taking three values, 2.48, A1 is 2.48 centimeters meter seconds, like that we will take units later. 2.46, so A3 2.49, 2.48, 2.46, 2.49. Now, what is the true value of this? So, true value is nothing but mean. So, what is the mean value? All these we have to add. 2.48 plus 2.46 plus 2.49 divided by 3. Almost you will get 2.476 if you divide. 2.476 according to significant digits. This is having 3 significant digits. It should also have 3. So, 6 is greater than 5. Therefore, 7 will be rounded to 2.48. Already we discussed this. Now, this is the true value. Now, what is the absolute error in A1? What is the absolute error in A1 means? A true minus A1. So, delta A1 is going to be, what is true value? 2.48 minus, this is also 2.48. Therefore, there is no error in A1. Delta A2, 2.48 minus 2.46. Now, what is the error? 0.02. Like the delta A3, 2.48 minus 2.49. So, 0.01. So, this is about absolute errors in A1, A2, A3. Mean absolute error. So, delta A mean is equal to delta A1 plus delta A2 plus delta A3 by 3. You can add these 3 and divide it by 3. So, error always we have to add absolute errors. Here minus is there, but we have to add whenever you are doing addition for errors. Like the relative error, percentage error. So, delta A1 by A1 into 100. Delta A1 you got 0. 0 by 2.48 into 100. Therefore, so there is no percentage error in first value. Like the percentage error in second value. 0.02 by A2. 46 into 100. So there is no other option. You have to solve carefully this whenever you are solving in the exam. So these calculations you have to take care. If you remove into 100, that is relative error. If you multiply with 100, that is going to be percentage error. So this is about how we are going to get absolute error, relative error, percentage errors.